Okay. Oh. Hare Krishna. Hare Hare. Okay, let me introduce myself. Okay, my name is Ashwani Yadav, and I have done M.Tech in iiest, Sipur. Well, okay, when I say Hare Krishna means I'm talking about consciousness. I'm talking about senses to consciousness. Okay, I'm talking about awakening. Talking about consciousness. Okay, when you have awakening, you need God. Well, this is something everybody should know, and everybody should understand. This should be your aim. Senses to consciousness. Senses to consciousness. Well, when you do a study for this, if your destination is like this, your ladder, and this is your ladder your concentration, then the study will be really enjoyable. Okay, you can enjoy the study, enjoy the struggle, then definitely you can achieve anything. Well, I'm going to start electric field. Now, electric field due to charge disk, Okay, we have already studied due to ring shape conductor and rod, infinite rod, and different types of desired point we have seen, okay, in previous classes. Now we elaborate a little bit and starts with due to charge disk. Okay, so we want electric field due to charge disk. This is a disk, and its radius is r. This is disk and radius is r. This is r. This is center. Okay, and it is given uniformly charged and say positive charge. Okay. And we defined a point function, that is sigma, that is surface charge density. So, well, and we are interested in finding the electric field at a distance x from the center of the disk. Okay. So, we want to calculate the electric field at this point. Now, question arises, how will you compute the electric field at this point? Okay. Take a ring. This is your elementary ring cut from the disk. Radius r. This is elementary ring of radius r and thickness dr. This thickness is dr. Okay. And contribution of this ring to the electric field will be in this direction, in axial, this direction. All that is dA, dx. This is due to the ring. Okay. We first develop an expression of electric field dx and integrate it because it is a continuous body. Okay, this is the step we have followed. I know. Yes, it is clear. First, you find unit area or a finite area considered from this distributed charge distribution, and then you, with the help of surface charge density, it should be defined. It is a point function. When you multiply this area, you find the dq. Okay, and you have already expressions for the electric field due to the ring at this point, and rest is just computing the overall electric field at this point with the help of integration. Just a simple mathematics. Now dq, what will be the dq? That is dA into sigma, and dA is nothing but 2 pi r dr into sigma. This is dA. When dA is 2 pi r dr, integrate it. What will you get? 2 pi r square by 2, we get pi r square. So total area is pi r square. So this is your elementary area dA. You differentiate it, you will get 2 pi r dr. Okay. Now we have already computed dx due to the ring electric field. We have dq by 4 pi epsilon naught x by x square by r square 3:2. Okay, now you can put here dq is nothing but 2 pi r dr sigma by 4 pi epsilon naught x square plus r square 3/2 into x. Okay. Now we have pi is going to cancel. 2, we have sigma x is constant 2 epsilon naught integrations from 0 to r, sorry, it is r, total radius r, total is r, and we have left with r dr x square plus r square 3:2. Now, okay, so why you should consider x square plus r square is equal to t square. Now x is constant, differentiating both the side we will get 2r dr 2t dt, and then up alag. Now you do the calculations in rough. Okay, in these rough pages, you know, we have r dt dt, and this is t cube. We have dt by t square. Now t minus 2 dt integration, we have t minus 2 plus 1 minus 2 plus 1 is equal to minus 1 by t. Okay, so this is your result. You put t is equal to under root. Now we have minus 1 by under root x square plus 1 by r square. This is your integration. Fine. Okay. So we have sigma x 2 epsilon naught minus 1 by under root x square plus r square 0 to r. Now sigma x by 2 epsilon naught we are left with equation why don't you reverse this and eliminate the negative charges? You put x, you will find 1 by x minus 1 by under root x square plus r square. Well, just I have interchanged the limit, and when you change the limit, negative signs come and it will make positive. So we have now sigma by 2 epsilon naught 1 minus x by under root x square plus r square sigma by 2 epsilon naught 1 minus cos theta, and this cos theta is I have okay, this is your ring, you know, this was our figure, and this is r, and this is theta x under root x square plus r square. Okay, cos theta is nothing but x by under root x square plus r square. So we have sigma by 2 epsilon naught 1 minus cos theta. When radius is very large, then cos theta is going to be 90 degree. So this angle is going to be 90 degree. Look at this. When you increase the radius, then we have x by r, and r is very large, so you will get it 0. Then theta is equal to 90 degree. Okay. So we have left with 1 minus 0 if disk is very large. Disk is very large. When this is very high, it will become 0, tends to be 0. Then sigma by 2 epsilon naught, and it becomes uniform, not varying with a space coordinate with x. Okay. When we have infinite shape, say not infinite, is practical possible? We have infinite shape? No. Radius is going to be somewhat maybe 20-30 times bigger than x. Then you can assume it as large or very large. Then we have electric field component is going to be uniform and not varying with the space coordinate. Otherwise, we have this expression sigma 2 epsilon naught 1 minus cos theta. Okay. So, infinite charge sheet. Okay, this is your infinite charge sheet, positive charge, say uniformly distributed. Then electric field in x direction is going to be uniform. Okay. And Ey is equal to 0 because due to symmetry. You understand this? The symmetry cancels the electric field. Take this point here. It will, the component is going to be cancelled out in y direction. Okay. Now consider this is semicircle. This is semicircle, and given a charge q uniformly distributed. Okay. And radius is r, and lambda, you know, we have given linear charge density, Now compute the electric field generated at center, Okay, this is a question. Look, you take this a small element, finite element, a length dl, it has dq lambda into dl, and suppose this is theta and this is small d theta, then you know dl is nothing but r d theta. So dq is equal to lambda r d theta. And similarly, you know, it is symmetric. It is look, this is symmetry about this axis. So we are wise enough to take another element of making equal angle theta dl. Why? Because and from Coulomb's law, just join this line. This is direction of the electric field, and you know this component is going to be cancelled out. So we are not getting any component in this direction. We are left with only y direction. Okay. This is theta and this is theta. So we just need to develop electric field expression for this finite charge, and the rest we will follow the same thing, integration process. Okay, and it will give for the all the you know semicircular ring. We add this small element, and addition, you know, for continuous body is interchanged with continuous, sorry, with integration rather than summation. So we have dEy is nothing but dq by 4 pi epsilon naught by r square. This is radius, and dq, sorry, we are writing with big R, lambda r d theta 4 pi epsilon naught r. Since this is d and Ey is cos theta, you have to write cos theta. This cos theta is just component of net electric field in this direction. Okay, so electric field will be the along symmetrical line. Remember, if charge will distributed, so it cancels anything. If we want the electric field at symmetry, then we have one component. Due to symmetry, Ex is going to be cancelled out. Okay, well, now we have a small calculation. Cos theta d theta 4 pi epsilon naught r is going to be cancelled out. Okay, so we are left with integration. We will get Ey. So Ey is just integrating this function lambda by 4 pi epsilon naught r cos theta d theta. Okay, now this theta, if you want to take all this small element, you have to travel in this direction, and from here you have to travel in this direction, from 0 angle to pi by 2, from 0 angle to negative pi by 2. Negative means in reverse direction. Okay, then we have limit of integration is minus pi by 2 and pi by 2. So we have lambda by 4 pi epsilon naught cos theta minus pi by 2 to pi by 2, and this is going to be, you know, we have computed this value earlier, and it is going to be 2 sin theta, and sorry, here r is going to be lambda by 2 pi epsilon naught r, because it will become 2 and going to be cancelled 4 by 2. So we are left with this result, and in this direction. Okay. Now I just want to play with these expressions, with just want to modify something so that we can make it more interesting. Okay, why we should some questions born in my mind. Why don't only pi, this angle is pi, make it some different angle? Suppose this is arc. Okay, this is arc, this is arc. Similar way, this is arc and this is same line charges. Okay, and this is center, and maybe I don't say this is equal, maybe different angle. Suppose this angle is theta 1 and this angle is theta 2. Theta 1 is not equal to theta 2. Well, so we have ex, and this is not symmetry point now. So center is not symmetrical point. Okay, if theta is not equal to theta 2, well then ex is say is in y directions. Okay, and just we are considering here ex, so we can write ex is nothing but with same expression lambda r 4 pi epsilon naught r square cos theta d theta minus pi by 2 to pi by 2. We have left with lambda by 4 pi epsilon naught r. Again we are repeating the same expression, but if we know this, sin theta 1 minus sin theta, plus sin theta 2. Sorry, here minus theta 2 to theta 1. Okay, this is your expressions. If theta 1 is equal to theta 2, then we have the expression lambda 4 pi epsilon naught r 2 sin theta 1. So we have final expressions 2 pi epsilon naught r sin theta. This is ex. Now we can write ey. We can similarly develop an expression for ey with the use of same expression. Now ey at this point, ey, okay, and this is ex and ey, maybe in downward direction, maybe in what, depending upon which contribution is higher. Okay, this is going to be downward is component and this is going to be upward if this angle is going to be larger. Okay, depend upon the contributions, we see whether it's going to be downward or whether it's going to be upward. X is in just positive x directions. Okay, similarly, with I want to just keep the same in a computation. We can just write lambda, sorry, it's going to be 4 cos theta 1 minus cos theta 2. Okay, so which one, when theta increases, it is going to be diminishes. Theta 0 is equal to 1 and 90, it is going to be 0. So as theta increases, cos theta value decreases. If theta 2 is going to be, if theta 2 is greater than theta 1, this means this is smaller. Then we have positive value of y. Okay, then ey is in this direction. If theta 2 is greater than, if theta 1 is greater than theta 2, this means cos theta 1 is less than cos theta 2. Do you understand this? Okay. You see, this is like this. It decreases with this is 0 degree, the maximum, and when you increase the angle, it is going to be 0. This is the function of cos. So when theta increases, value of cos theta decreases. So in this, when this happens, this angle is greater than this one, then it's going to be downward. Okay. Then Ey is in negative direction. Is in negative means downward. It depends upon you, but you have to understand the direction. Okay, downward, negative, negative j. Okay, whatever. You should enjoy or appreciate this thinking. Ey downward direction. Well, now you are able to compute the electric field expressions of this arc. Okay, do you understand? This is for similar, more or less similar. The r is here radius only, and this is same for line charges. Okay, so if you connect the formulas, it will be very easy for you to learn and remember. Now we have a question, some illustrations, and this is from Irodov and also from BM Sharma. Same questions have been given in both books. Okay, so a long wire with uniform charge density lambda is went in two configuration shown in figure A and B. Determine the electric field intensity at point O. Okay, so this is your figure 1. This is your wire, and it is going to be very long and making an angle and this one is like this, and this is your semi like this, and going to be like this. Now this is your 90 degree and this is your center. So you have to find the electric field at this point. Okay, now another configuration, you see like this semicircle, and this is radius r, and this is r, this is r, and lambda. We have to find the electric field at this point. This is question asked, you can see in irodov, but we have already developed the expressions for each segment. This is, I tell you, this is long wire, and this at the end point we have developed this electric field expressions. Ex is nothing but lambda 4 pi epsilon naught r, and downward lambda by 4 pi epsilon naught r. This is I, and this is minus j. Okay, And for this one, look, this is going to be positive, then but electric field will be just opposite to this one. You can apply the similar conditions, and with little wisdom you can also find you are wise enough, okay, so you can think it will look at this line. So this way you have lambda by 4 pi epsilon naught for segment 2 r j, positive j, okay, and in this directions, because for this wire we have lambda by 4 pi epsilon naught r minus I, and when we you see add this is going to be cancelled out. So for segment 1 and 2 we are not getting any electric field, it is contributing none because getting cancelled out, okay. So we are now left with this circular segment, okay. So both wire electric field due to segment 1 and segment 2 in very long wire, this is contributing 0 at this point, cancelled, okay. The effect is going to be cancelled out, but we have segment 3, so resultant will be due to segment 3, okay. So this is 90 degree and this is center. So we want the electric field at this point, so we can take a small dl subtend an angle d theta, and this is theta. So dq is nothing but lambda dl and lambda r d theta, and it will make an electric field in this direction. So dE we have lambda r d theta 4 pi epsilon naught r square, and this is angle theta. So in these directions component of d will be d cos theta, and this direction will be d sin theta, okay. So dex we have lambda cos theta d theta four pi epsilon naught r. Now when we integrate this, we will find a ex. Now ex on integration lambda cos theta d theta 4 pi epsilon naught r lambda 4 pi epsilon naught r integration of cos theta d theta 0 to pi by 2, it is equal to 1. So lambda by 4 pi epsilon naught r, and again E by we have lambda by 4 pi epsilon naught r cos sin theta d theta and 0 by 2 by pi, it will again give 1, okay. So we are left with lambda 4 pi epsilon naught r. So Ex and Ey are both equal. So Ex and Ey are equal. So we have, due to this half quarter, half of semicircle, it is just quarter, we have electric field like this. Okay, here in this direction lambda by 4 pi epsilon naught r, and in this direction lambda by 4 pi epsilon naught r. So we have the configuration like this, and this is going to be 90 degrees. So its component in this direction, this and this. So here lambda by 4 pi epsilon naught r and lambda by 4 pi epsilon naught r, and it is in perpendicular direction I and j. So E net we have, because it is perpendicular, so we can write lambda by 4 pi epsilon naught r whole square plus lambda by 4 pi epsilon naught r whole square, and final result we have 2 root 2 will come under root, this will be under root, and 4 by epsilon naught r. So this is your answer due to the first configuration. Now second question, question number second. This is question of irodov, but I don't find any difficulties. Okay, do you think it is difficult? Now this is 1, 2 and 3. These directions, it has lambda by 2 pi epsilon naught r, it is in j direction, and this is segment 1 and this is r. So we have in this direction lambda by 4 pi epsilon naught r, this is I, and downward lambda by 4 pi epsilon naught r j, and this one for segment 3, and this is r. So downward we have lambda by 4 pi epsilon naught r, downward you can say negative. Well, and one component in this direction, that is lambda by 4 pi epsilon naught r minus I. This positive I minus I, same energy is going to be cancelled out, and downward we have minus, just add this lambda by 2 pi epsilon naught r j. This is minus and this is positive. So E net is going to be 0. Okay, but you can you answer in just second? Yes, this is point of symmetry. So whenever you find the point of symmetry, because look, these things lie on the point of symmetry. Okay, this is point of symmetry, and this lie in this point. Then we have already discussed in the other classes. So electric field will be 0. Okay, no need to solve, but just we have expressed the expressions of electric field so that we can be habitual of this writing, and we can learn it keeping in mind the expression of the electric field. Now one more question. Suppose this is hollow hemisphere uniformly charged distribution sigma, and this is nothing but coulomb per meter square, and this is center. No, this is center. So find the electric field strength at C. Okay, at center. Okay, this is your question. So how can we proceed? Okay, just okay, this is question. I'm going to make it some larger, so that it becomes some easy to visualize and clear picture. Sorry. Okay, this is your center and this is your radius. So we take an elementary ring. This is ring. Okay, this hemisphere, when you go behind this, you will find this like this total perimeter about this surface. Okay, so this is a ring. This is going to be ring. This is elemental ring. Elemental ring, and width, and this is making an angle d theta. So this is r d theta thickness, and this is going to be r cos theta, this much. This is theta, and this is r sin theta. So due to this ring, we need to develop an expression to find the electric field at this point. Once you are able to write compute the value of electric field due to this elemental ring, this area contains some charge, and this charge stationary will produce electric field at this point, and we know the ring will produce electric field in this direction. D, consider this is axis is x, then we have dx. Once you write this equation and perform the integration, okay, then it becomes very easy. Now we have, don't designate as with x, just write dE, then dE for ring. Okay, then we can write dq 4 pi epsilon naught x square. This is x square, this is distance, that is r square cos square theta, plus this radius of the ring r square sin square theta 3:2, and this is x distance r cos theta. Okay, now what will be the dq? Now write dq sigma and area of the ring 2 pi r sin theta and r d theta. So we have sigma 2 pi r square sin theta into d theta. Just put this expression of dq in this in an equation. This expression we have sigma 2 pi r a square, then we have our cube here, cos theta sin theta d theta 4 pi epsilon naught with power 3:2. We have r square, then we have r cube r square is going to be r square cancelled out. We have left with r cube. So now expressions will become very simple. Is going to be sigma pi sigma by 2 epsilon naught okay, and this is going to cancel out. We have okay, don't cancel it, because 2 sin theta, it will give sin 2 theta d theta, and you know this from this angle, and this like this is going to cover the whole area when theta starts from 0 degree and starts rotating in these directions and starts from 0 degree to pi by 2. So 0 degree to pi by 2, this will be your okay, and we all know that this value is equal to 1. You can solve this. You can find integration of sin 2 theta 0 to pi by 2. This will give the value of 1. Okay, 0 to pi by 2 sin theta, when you integrate it, it will always give 2. Okay, so we are left with electric field 4 by pi epsilon naught. You can just perform integration if you want. This will cos 2 theta sin ka integration 2 theta, this is minus by 2. Now 0 to pi by 2 you can put here cos 0 1 and will be half plus, if you take integration half, then cos 0 1 plus pi by 2 cos pi minus 1, it is equal to 1. Well, so we can find the electric field in these directions passing through the center, that is equal to sigma by 4 epsilon naught. This is uniform, okay, and this is uniform, not varying exact value, not in expression of radius. Okay, so another question. Now we have ring. Look at this. This is ring of radius r. This is ring of radius r, and this is radius r, and this is very long wire. Positive charge, it's kept like this. This is long wire, and uniformly charged, and this is lambda, you can say lambda per unit length. Sorry, we have total charge Q. This is the total charge on ring, and uniformly distributed with the point function lambda. Okay. Now we have find the interaction force with electrostatics. So we have to find the interaction force. Both have charge between ring and thread. Okay. How can we do this? We will consider the electric field due to this ring at we will consider this one dl length having charge dq, that is nothing but lambda dl. Okay, and we know this is distance x, this is distance x, and we know field due to the ring and field, electric field into force. What will the df, dx and dq? This will force. When you perform the integration, it will give the total force. This means force integration performed with the function ex and dq. So this length is, you can say, dx, because we have considered x, dx. So we have ex and this is lambda dx. So you know this is due to the ring. We know what is the electric field due to the ring. Ex qx y. May I write k for 1 by 4 pi epsilon naught k qx x square plus r square 3:2 lambda dx, and integration this will length 0 and to be infinity. Well, now we can just simple integrations. This is simple mathematics. So kq lambda is constant, so you can keep it out. So we have left with x, so dx x square plus r square 3:2. So again we have done this. Why don't do in the rough? X square plus r square by our t square, then 2x dx is equal to 2 dt. Now you can put here t dt by t to the power cube 1 by t square dt. This is nothing but minus 1 by t. Okay. So we have f is equal to kq lambda 0 to infinity 1 by minus kq lambda minus 1 by under root x square plus r square, and write this minus 0 to infinity. So we have kq lambda. When you put infinity, it will become 0, and when you put r is equal to x is equal to 0, we have left with r. So we have 1 by 4 pi epsilon naught q by lambda into r. This is your total force of interactions between this wire and the ring. Okay. Okay. One more question on similar theme. Just you need to compute the force interactions between two configurations of charges. Okay. Now question 2. mutual perpendicular long straight conducting rod carrying a current, carrying a uniformly distributed charges of linear charge densities lambda 1 and lambda 2 are positioned distance A from each other. Okay, how does the interaction occur? So, how does interaction depend on A? Okay. So, two mutual perpendicular straight conducting rod carrying a mutual perpendicular rod. Can you understand this? How it is located? It is like this. This one. This is your other wire. This is your wire like this, and this is another wire like this. Okay, you can see this. It is in this direction, another one is perpendicular, but this distance is A. Okay, this is distance is A like this, and another one is like the wire is like this. Okay, and this distance is A. When you see this, what do you find? You can see this front view. Okay, do you understand me? You can see this front view. One may be like this. You can see the wire, another wire is like this. Okay, this is perpendicular to each other, having maintaining a distance A. Separation of distance is A, and you see this point. You see this front view. Front view will like just a point. So I can write this front view just like a point, and this one having length L. So this is a question. Okay, now you have to find the expression of electric field interaction, and this is maybe lambda 1 and this for lambda 2. Okay, just take an infinite length dx, and suppose this length is x, and this is like this. Okay, similarly you can take this component, and you can find electric field in this direction, and it has two components. So E and E is going to be same. So this is opposite direction. So we are not getting any component in this direction, say x direction. So we are left with only downward or y direction, EY. So net electric field will be in this direction, EY. So net force will be in y direction. Okay, E is going to be cancelled out due to symmetry. Well, so once you are able to find E electric field and then multiply with a small dq, then we will get a small df, and when we express the whole length, we can develop expression for force. This is very simple question. Okay. And this is, you can say, angle theta, and this is your A, and this will be hypotenuse perpendicular a square plus a square. So what will be the dE? Nothing but lambda 1 4 sorry, it is very long, then 2 pi epsilon naught 2 pi epsilon r. R is nothing but a square plus x square. Okay. Now what will be the dq? Lambda to dx. Then we have a small df, lambda 1 2 pi epsilon naught under root a square plus x square lambda 2 dx. So when you perform integration over this expression, you will get f. So f is nothing but lambda 1 lambda 2 dx 2 pi epsilon naught under root a square plus x square. Well, sorry, and we have to also take this angle theta. So df in downward directions, we have to consider cos theta. So we will consider cos theta. So f is lambda 1 lambda 2 2 pi epsilon naught. Cos theta is nothing but this is p b by h, and we have a, this is b, h is x square into under root a square plus x square and another a square plus x square, and this is dx. So we have force is lambda 1 lambda 2 a 2 by 4 epsilon naught. So we will perform integration over this expression. We have dx a square plus x square, and since it is very long, so integration will be performed over whole length. So f we have minus pi by 2 to pi by 2 lambda 1 lambda 2 2 pi epsilon naught a dx a square by x square. Sorry, this is not angle, this is length minus infinity to infinity. Lambda 1 lambda 2 2 pi epsilon naught okay, and a minus infinity to infinity dx a square by x square, and all you know the integration of dx by a square by x square is tan inverse a 2 pi epsilon naught is 1 by a tan inverse tan tan inverse x by a, and this is minus infinity to infinity, and lambda 1 by lambda 2, this is going to cancel out 2 pi epsilon naught and this is going to be pi by 2 plus pi by 2. Okay, infinity pi by 2 minus plus pi by 2, and you add this, it will becomes pi, and pi is going to be cancelled out. We have left with product of linear charge density 2 epsilon naught this is not depending upon A. So this is your force, electrostatic force interaction. Okay, we will do some more problem in next classes. Thank you.